Hmm. Oh, well, I don't think that they can penalize anyone for not taking the Euclid this year. So, hmm, that's strange. Yeah, I wonder how they'll. I mean, I'm sure you could email like an advisor there. And in university, speaking to advisors is a very normal thing to do, because it is challenging to navigate the university system, right? It's complicated with credits and prerequisites, and there's also like there's many like prerequisite waivers and everything, and I can imagine that yeah, if you know a certain score in the Euclid is a requirement for a certain exam, then I'm sure there's other ways of getting around it this year. So I would definitely look into that. Do you know how to access a student advisor? Okay. Okay. With the calculus class? Yeah, I mean certainly Waterloo's first year calculus class is going to be kind of like calculus on steroids. Like they'll go pretty far. Um, yeah, wow, that's a lot to think about. Cool. Um, yeah, yeah. Okay, so let's get started. But if you wanna talk more about Waterloo, I'm available this weekend or even after exams too. I'd love to chat more about it. Um, yeah. Okay. So we're gonna look at a couple things now. I'm just making sure that the YouTube video is on the website, and it is now. Just gotta publish it. Okay. And so we're on our last unit review. So this is a big deal. So this is the final unit, Unit 10, um, and Unit 10 is kind of narrowed down for us, which is kind of nice. So I went through here and I listed all of the topics from Unit 10. Normally, Unit 10 is one of the longer topics. It's 15 topics long. But it's been narrowed down to what is that, 6 topics or 5 topics? Yeah, 5 topics. So I'll go through them all because they should for the most part be a review. I think we skipped a couple of them just to save a little bit of time, but for the most part these are going to be a review, so I'll go over them fairly quickly. So obviously we have convergence and divergence. So I'm kind of surprised that this isn't on it. But I mean, I think it's worthwhile just to circle it anyways because we should know what it means for a series to converge or diverge. So it's not technically a topic that will be tested, but I don't know how they could like avoid it without like while simultaneously including these other topics. So in any case, convergence and divergence is the first topic. Then geometric series, and you will be tested on geometric series. The nth term test, I guess that's not something that they'll be testing. So yeah, we don't really have to get too much into it. The integral test, not going to do that. A harmonic and P series. So being familiar with series that have some ends that look something like this, x to the p, right? And looking at for which values of p, so something like this, you know, p equals 1 to infinity, right? So something like that, like for which values of, or sorry, n equals 1 to infinity, blah, 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 blah. So like for which values of this do we converge? The comparison test, we're going to skip that. The alternating series test, so yeah, we looked at that. So when does an alternating series converge? So basically you look at whether or not they're monotonically decreasing as they get smaller. The ratio test, so this is kind of one of the more popular tests where you look at the ratio between terms and you see what happens as we get further and further away from the first one, and basically take the limit of the ratios. And if that ratio is less than 1, then we converge. And then absolute conditional convergence, we skipped that. So that wouldn't have even been a review if it was on the exam. Alternating series error bound, again, we skipped that. Taylor series, we know all about Taylor series, but we skipped Lagrange error bound. Basically, Lagrange error bound is saying, okay, if you have a Taylor series that approximates a function, the Lagrange error bound tells you how accurate that estimation is. We've got the radius of convergence. We did a few questions on that. Taylor-Mclaren series, again, it's, we're already doing Taylor series, but I guess Mclaren series aren't going to be tested. And then finally, a power series from a function. So basically, like, when can you get like a perfect power series, or like a Taylor series from a function that fully represents the function. So yeah, this is going to be I guess sort of one of the shorter ones. I found an FRQ that covers pretty much, no, not all of these. I shouldn't actually say all of these, but it talks a lot about the Taylor series. And one of the questions on the FRQ that I chose today asks about the error bound. We're just going to skip that because there's no point. I shouldn't say there's no point, but it's not going to be beneficial for our studying. So let's take a look at this question. Okay, so it is, where did I put it? It's somewhere on here. Here it is. And I'm gonna have to zoom in because their font is so small. There we go. Okay. Okay, so let's take a look at this FRQ. So this is Unit 10, and I didn't write out the whole thing this time, so we'll have to kind of bear with me here. So this is Unit 10 FRQ Part B. Okay, so this is the second one. I assigned Part A for you, so that's what your responsibility is. I'm doing Part B, and the question is, so they're given, they give you this function f of x, and they're giving us a Mclaren series for f of x, and f of x is going to be this function here, x minus x cubed over 3 factorial. Plus x to the 5 over 5 factorial minus x to the 7 over 7 factorial plus dot 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 plus, and the general term for this is, what is it, negative 1 to the n, I mean you could probably figure it out just by looking at these terms, times x to the 2n plus 1 all over 2n plus 1 factorial. Okay, so that's our general term. So they're saying that this Mclaren series converges to f of x. Now I know that Mclaren series aren't actually going to be on the exam, right? Because that's number 14. But that's kind of neither here nor there, because they're giving this to us. This section here is saying, like, given a function, find the Mclaren series. We are given this Mclaren series. So we're given this Mclaren series. It converges to f of x, so that means that they're equal to each other as n tends toward infinity. You get a perfect match. So yeah, so it is, yeah, so this converges to f of x for all real numbers. So the radius of convergence is infinity. So for any real number x, we get an exact value of f of x when we plug it into this Mclaren function. Now they also say let g of x be equal to f of x squared. Okay. So part A is to find the first 4 non-zero terms and the general term for the Mclaren series for G. So let me write that out. So find the first 4 non-zero terms and the general term for G of X. Okay, so I'm gonna let you try this one on your own. I'm gonna give you a few minutes, and then I'll kind of interrupt you, and then see how you did. And so this one I don't think should take too long. I'm gonna give you maybe 2 minutes. Yeah, I'm gonna give you 2 minutes, and hopefully that's enough time for you to at least get a sense of what the question is asking and to start it, and maybe you can even finish it too. So 2 minutes starting now. Okay, time's up. So let's see how we did. So the idea here is that g of x is pretty much the same as f of x, except instead of seeing an x, we see an x squared. So so that's what we're gonna do. So let's just write out f of x. So I'm gonna write f of x, and that's equal to, well, I'll just copy this whole thing out. So these are the first 4 non-zero terms. So x cubed over 3 factorial plus x5 over 5 factorial plus x to the 7. Oh, that should be minus over 7 factorial. Make that look actually like a 7. So that's the first 4 terms of f of x. So f of x squared, is going to be, well, this is going to be x squared. I'm going to put the whole thing in brackets here, x squared minus, okay, I've got x squared cubed over 3 factorial plus x squared to the 5 over 5 factorial minus x squared to the 7 over 7 factorial. Okay, so notice that the denominators don't change, right? It's not like the factorials are now doubled as well or something like that. It's just the x's. So let's just clean this up a little bit. This is going to be x squared minus x to the 6 over 3 factorial plus x to the 10 over 5 factorial minus x to the 14 over 7 factorial. Great. So let's find the general term. We still need to find the general term. So I'm going to find the general term over here. I'm just going to copy and paste it to save a wee bit of time. Oops, didn't mean to cut it. There we go. And paste it. There it is. Okay, So I'm just gonna say that this is the how do I do this? Okay, I'm just gonna put an arrow saying I'm gonna take this and turn it into, well, negative 1 to the n times x squared to the 2n plus 1 all over 2n plus 1 factorial. And again, I've got to clean this up. So this is going to be negative 1 to the n, probably blocking that with my head. Okay, negative 1 to the n times, well, 2 times 2n is 4n, so I've got x to the 4n, 4n plus 2, right? Remember, we have to use that distributive property, and the denominator stays the same, 2n plus 1, in brackets, factorial. Okay, so this would be the general term for g of x. So there it is. Okay, any questions about that one before we move on? Oh, it doesn't sound like it. Okay, let's see if I can. It kind of looks that way. Yeah, I think this is sine of x, because the first derivative at 0 would be sine of, yeah, so the first derivative would be cos of x. Cos of 0 is 1, and then sine of gosh, hurts my brain, but yeah, I think, I mean, this looks like sine of x. Yeah, and they're alternating. Let me just double check. Taylor series for sine of x. I think you're right. Yeah, x to the 2n plus 1 over 2n plus 1 factorial. Yeah, you're right. Good catch. So that is sine of x. So I guess this other one is sine of x squared. Cool. Okay, let's do the second question. And AP Classroom wants to kick me out, but here it is. Okay, so question B is find the limit as x approaches 0 of x squared minus x to the 6 over 6 minus g of x all over x to the 10. Now, I'm just going to just go out and say this. This is a huge exercise in algebra. This question has very little to do with actually taking a limit. So don't think that, like, okay, the limit here is like there's some crazy trick. Think about the algebra. See what you can do to simplify this. The first step, I'm just going to give you a couple of hints. The first step here is to, replace g of x with this thing here, right? And this is the general formula. So replace it with that, with the sum of like whatever this thing is. That's the general term. So replace that with the infinite sum. And then see what happens. Okay, so this one, there's a fair amount of algebra to do in this one. You could probably do it in a couple of lines if you kind of know where you're going and you kind of can have some foresight to see what you want to happen. But if you don't know what you're doing and if you don't really have an idea of exactly where you're going, you might kind of loop back and you may have some difficulty. So I'm going to give you 4 minutes with this one. And in 4 minutes, I'll come and cut you off and see how you did. I'll give you the general form for g of x as well, just so you have it on hand. Copy and come on, paste. So remember that g of x is the sum where n goes from 0 to infinity of this thing. Okay, time's up. All right, so yeah, let's just start attacking this thing. What I'm gonna do is I'm just going to I can see myself making this mistake 100 times. I'm gonna leave the limit out of it, and I'm gonna bring the limit in at the last minute. Okay, so I'm just gonna focus on the expression. I'm going to see if I can simplify the expression. Now the problem with this limit here is that we've got a bunch of x's in the denominator, right? So as we take the limit as x approaches 0, it looks as though it's going to be going to infinity or something, right? Because we've got a whole bunch of x's in the denominator and not enough x's in the numerator. So let's see what we can do to see if we can try to cancel anything out in the denominator. So I'm just going to copy out this expression. I'm going to write x squared, oops, what the heck, x squared minus x to the 6 over 6 minus g of x all over x to the 10. Okay, and I'm going to just start attacking this. This is what I'm going to be sort of focusing on, is seeing if I can simplify this in any way. So I'm going to replace this g of x with it's like the sum of the general term. So I'm going to write x squared minus x to the 6 over 6 minus well, let's see here. I've got this thing here. It's the sum from n equals 0 to infinity of -1 to the n times x to the 4n plus 2 all over 2n plus 1 factorial all over x to the 10. X to the 10. Okay. Now let's see what we can do about this. So, I wonder if we recognize any of these terms here. So let's take a look at this thing right here. So if we look at this, we've got x squared minus x to the 6 over, well, 3 factorial is actually 6. So this is actually, so these two terms are this term right here, right? So why don't we rewrite this? Why don't we extract a few of those terms and then see what happens? Okay. So what I'm going to do is I'm going to extract the first 3 terms in this sum, and when I do that, I'm not going to be starting my sum at 0 anymore, right? So if I were to say take out the first 3 terms in here, well then I would have taken the 0th term, I would have taken the first term, and I would have taken the second term. So that means that I'm going to have to take this sum starting at n equals 3 after I've taken the first 3 terms out of this. So lucky for us, we already know what the first 3 terms look like. They're these 3 terms right here, right? That's kind of why we did this question first. That's why they ordered the questions in this order. So we're going to take these 3 terms and just throw them in this numerator, and then all we have to do to the sum here, all we have to do here is just change the index to start at 3 instead of 0. So let's try that. Okay, when I do that, let's see what happens. So this is equal to, well, the first ones stay the same. I'm just going to write x squared minus x to the 6 minus 6 minus, now I'm going to have to throw some brackets in here because we are subtracting this, so I do have to make sure that that negative sign is going to distribute. But let's go ahead and I'm going to copy these 3 terms. I'm just going to straight up copy them like this, copy, and I'm going to paste this. And you might say, okay, well, why are we doing the first 3 terms and not just the first 2 terms? Well, if you notice here, like here's kind of our blueprint. This is what we should be looking at because we already have the first few terms. Now I see an x to the 10 here, right? Here's an x to the 10. So I know that if I pull this term out, I'm going to have x to the 10 in the denominator and I'll have it in the numerator. So that will cancel out those terms and that'll give us something meaningful, okay? So I'm going to finish writing out this equation. The denominator is x to the 10. And I think I'm going to need a little more room here, maybe that much room, to finish writing the sum. And this is plus the sum from n equals 3 now. Now I'm starting at 3, not at 0, because I've extracted the first 3 terms. So I don't get to include them twice, right? So I have to make sure that my sum is starting from 3. So I'm going from 3 to infinity of negative 1 to the n times x to the 4n plus 2 all over 2n plus 1 factorial. Close my brackets. I'm going to write this x to the 10 over here. Okay, now you can start to see what's going on here. Maybe you can see what's going on here. Okay, now I can start canceling some terms. So I've got this x squared and this x squared. They cancel out. Remember, because I'm subtracting them. I've got this negative x squared over 6, and that's what this is, right? Another negative x squared over, well, 3 factorial, which is 6, right? And remember that I'm subtracting this. So it's almost like I'm adding, this term, or it's not almost, I am adding this. So I've got negative plus, and these cancel each other out. Nothing cancels with this x to the 10 over 5 factorial, but it's probably worth pointing out that 5 factorial is 120. Okay? So let's rewrite this big, huge fraction, and we'll try to simplify it a little bit. So I've got x to the 10 over 120 plus the sum from n equals 3 to infinity of negative 1 to the n times x to the 4n plus 2 all over 2n plus 1 factorial all over x to the 10. Okay. Now what's up? Yes, it is. Thank you. And this whole thing should be negative, right? The whole numerator should be negative. So how about, instead of doing that, I'll put negative x to the 10. But if you wanted to, yeah, you could have a minus sign here and a minus sign there. That would be fine too. But yeah, thanks for the catch. Okay, I'm gonna split this up. I'm gonna turn this into 2 sums. So I've got x to the 10 over 120 over negative x to the 10 plus the sum from n equals 3 to infinity of negative 1 to the n times x to the 4n plus 2 all over 2n plus 1 factorial. All of that, let me do that again, all of this is over x to the 10, negative x to the 10. Okay, so this thing here, this is fairly straightforward to calculate, right? So basically the x to the 10s cancel out, and I get negative 1 over 120. Okay, so that's pretty nice. Now let's think about this thing here. So remember that this is going to be a limit question, right? So x is effectively going down to 0. Now let's take a look at what these terms are going to be. The very first term of this sum is going to have, well, the first one is n is going to be 3, right? So let's take a look at what's happening with x here. So in this case, we're going to have x to the power of 4 times 3 plus 2. So x to the 12 plus 2 is x to the 14, right? x to the 14 over x to the 10 is x to the 4, right? So the very first term here is going to have x to the power of 4. And then each time we're going up by 2. So the next one will have x to the 6. The next one will be x to the 8. What I'm trying to say is this limit, x is going to 0. So that means that all of these are going to be 0 in our limit. So we'll just have one term that goes to 0, another term that goes to 0, another term that goes to 0. All of the terms go to 0. So we've got the limit. Well, here, let me finish writing this out. This is going to be, I'll say minus the sum from n equals 3 to infinity of negative 1 to the n. And what I'll do here is I'm going to distribute this x to the 10 into the sum. So then now that's going to be actually part of the sum. So we'll say that this is going to be x to the 4n minus 8 over 2n plus 1 factorial. Now, this 4n minus 8, I'm wondering if anyone has objections or questions about that. Do we all understand why this is 4x to the 4n minus 8? Speak now or forever hold your what is it? How does that go? Speak now or forever hold your... Yeah. Yeah, so okay. Basically what's happening is that we're dividing by x to the 10, right? So then that's like subtracting 10 from the exponent. So all of these, since we're starting at n equals 3, these are all going to be positive. So we're going to have positive exponents on x. Therefore, the limit as x approaches 0 of, well, let's see what the original equation was. Let me just copy this. I'm getting sick of writing all this stuff. Copy this. Paste. There it is. Okay. So therefore, come on, where are you? There we go. Therefore, the limit of this thing is equal to the limit as x approaches 0 of negative 1 over 120 minus the sum from, let me just copy this too, because I'm getting tired of writing all this stuff. Copy, paste, and there we go. Okay. And as x approaches 0, this thing right here is going to go towards 0 because they're all positive, positive exponents. So that means that this is equal to negative 1 over 120. Okay. So like I said, a lot of algebra in that one. I mean, it wasn't too bad, but I think that sometimes it's easy to forget that algebra exists, and your first instinct can often be, okay, which crazy calculus theorem can I use to make this like a one-liner? It's like, no. Sometimes you just need to be patient and use some algebra and just really expand everything out. Look at the information that you already have, right? This drew on our information about what g of x looked like, the first few terms of g of x, right? So I think this was a great question. Now, part C is about the Lagrange error bound. So we're gonna skip that. So that's it for this question. So I guess that's pretty much it for today. So far I've spoken to I think 1, maybe 2 students about some of the questions on the FRQs that I assigned. Please don't hesitate to reach out. I know that this weekend is probably going to be maybe a bit of a stressful weekend, right? Like next week, we've got a big week. So if there's anything that I can do to help you out, like if you want me to walk you through some of the questions, I'll be there. Typically, I don't like to do too much hands-on stuff over the weekend, but this weekend will absolutely be an exception. If you need to reach out and you need some help with a problem or anything like that, I'll be on call pretty much the whole weekend. So my weekend is dedicated to you. So yeah, don't hesitate to ask for help. And keep in mind that the whole point of the FRQs that I've assigned is for you to actually practice them and to learn them and to get some practice under your belt before we actually do the exam. So I'm more interested in you trying them and stumbling and looking through your notes and relearning all the topics that you've learned throughout this past year than I am about just like you getting the right answer, right? So I think while I was walking through one student, it's not like I'm just going to give you the answer, but I'll push you in the right direction and yeah. So yeah, good luck this weekend. I hope that everything goes well. I was thinking last night about you guys, and I was thinking that I kind of wish that I was writing the exam too. I almost wish that I would be there with you, because I kind of like I feel that sort of nervous energy, the same kind of nervous energy that you're probably feeling. This is my first time going through an AP course as well. So yeah, I kind of feel like you guys are getting ripped off. That like, I'm done now, right? The burden is now on you. Like my job here is done. Well, I mean, like I said, I'll be around this weekend, but for all intents and purposes, our work here is done, and now it's up to you. So I feel like maybe that's a little unfair. I mean, obviously it's not. I mean, I'm your teacher, and I've spent over a decade in university, and I've done my fair share of exams and everything like that. But I still kind of feel some camaraderie with you guys. This has been a hard course to teach, and it's been a lot of fun. I've done a lot of learning. I'll be completely frank. Calculus was never my strongest area in math. I mean, that's not to say I'm not a good student. I wasn't a good student. I excelled more in algebra. That was kind of my area of expertise, algebra and combinatorics. That's where I kind of lived. But then calculus was always kind of ever since day one, it had always been a challenge for me. So this course was not a natural course for me. So I did do actually a lot of learning. As you probably knew, a lot of the time, if you asked a question, I wouldn't have the answer. I'd have to learn it with you. So it's been a big learning experience for me. And I kind of wish that I could write the exam too. That way I could, continue to learn alongside you and be a part of it. But of course I won't. But I'd love to hear about it. So I know that you guys have lots of exams, but after Tuesday, I'd love it if maybe we could try to maybe just arrange a time after the exam just to debrief, and maybe we could talk about it. Of course, maybe you won't be in the mood to talk to anyone after the exam. That happens. I know that when I was in university, there was always two types of people after the exam. There'd be the people who would want to talk about all the questions and, what'd you get for question 3, blah, blah, blah. And then there'd be the people who would just be like, you know what, I'm done. I'm going to go to bed now and wake up in 3 days. So there's, if you want to talk about it, I'd love to hear about some of the questions. Maybe afterwards on Tuesday, if you want to just log into Discord, I'll be around. I'd love to hear about the exam, because I'm very curious about how it's going to go. I'm also curious about the format and how that's going to work out. So if you want to debrief after the exam, I'll be around. And even if you kind of just want to complain about how awful it was and how unfair it was that you only have 5 minutes to upload your documents or anything like that, I'd love to hear your grievances, and I'd love to hear about any questions that you found interesting. Let's say, I mean, obviously it's optional, but if you want to log in after the exam, I'll make sure my Discord is or that I'm online on Discord, and I'd love to hear about a couple questions. I mean, not that we have to hang out for like a couple hours or anything, but maybe just a few minutes just to chat and catch up, and then afterwards, I think I mentioned last time, we're going to take a solid 2 weeks off because you guys have a whole bunch of exams right up until the 21st. So we'll take the full 2 weeks off, and we will start meeting up again on the 25th. Now, I should tell you, the last day of classes, of online classes, is the 19th of June. So we're not going right to the end of the month. Yeah, I learned this yesterday. Yeah, I learned this yesterday, that the last day of online classes is June 19th. And that's not to say that we can't communicate or anything like that, but just the last official class of this year is going to be on the 19th. And then after that, I suppose, will be time for exams or projects. Teachers are going to be writing report cards and that kind of thing. So that only leaves us a few more weeks. So if we're going to be meeting up on the 25th, that's let's see, come on, calendar, 1, 2, 3, 4 weeks. So we've got 4 weeks to get through the advanced math portion. But I think that should be really fun. I don't anticipate it being a stressful class. I think that it's just going to be a time for us to kind of maybe explore some different math topics. There's going to be a lot of opportunity to try different things. So yeah, I really like the idea of what that could look like. But we'll talk more about that on the 25th, because right now, you don't need to think about that. Right now, you need to think about your exams. Okay, so like I said, I'm going to be around all weekend. So yeah, don't hesitate to reach out, ask questions, or anything like that. But good luck, and if I don't hear from you before Tuesday or after Tuesday, if you're not really up for a debrief, that's fine. But if I don't hear from you, then I'll talk to you guys on the 25th. Okay, so best of luck. I'll be thinking of you guys. Okay. All right. Okay. Bye-bye, guys. And goodbye, YouTube. Good luck. Good luck to the 3 of you watching. Bye-bye.